Hello, today we are going to do an experiment to find the densities of two objects, one regular and the other irregular. We would be using a pebble, our irregular object, a cube, our regular object, and our apparatus, the displacement can, beaker, the measuring cylinder, and the vernier calipers. Now we would find the density of the cube. Firstly, let us determine the volume of the cube. The vernier calipers, please. First, we measure the length of the cube. As you can see, it is exactly 7 centimeters. Next, we measure the breadth of the cube. Again, we place the vernier calipers against the breadth. The reading is also 7 centimeters. Lastly, we will measure the cube's height. Again, the vernier calipers is used. The reading for the height is also 7 centimeters. Now to find the volume of the cube. The calculator, please. So the volume of the cube is the product of length, breadth and height, which will give me 343 centimeter cube. Finally, we measured the mass of the cube and found it to be 123.65 grams. Thus, the density of the cube is mass divided by its volume. So the density of the cube is 123.65 grams divided by 343 centimeter cube, which gives us 0.387 grams per centimeter cube, corrected to 3 significant figures. If we were to change it to SI units, the density of the cube is calculated as shown. Which will then give us 387 kilograms per meter cube. Next, for the volume of the pebble. The beaker and the displacement can, please. Now, to fill up the displacement can with water. We fill the displacement can with water to the brim. First, place the beaker under the spout of the displacement can. Then drop the pebble into the water of the displacement can. The amount of water that is displaced from the spout into the beaker is the volume of the pebble. Make sure that the water droplets stop dripping before you remove the beaker. Pass the measuring cylinder. We will pour the water into the measuring cylinder for a more reliable reading. Make sure that all the water is poured into the measuring cylinder. The reading is 14 millimeters, thus the volume of the pebble is 14 cubic centimeters. The mass of the pebble was 30.60 grams. Therefore, the density of the pebble is 30.60 grams divided by 14 cubic centimeters, which will give me 2.19 grams per centimeter cube, corrected to 3SF. To convert the density to SI units, we will have to convert 2.19 grams per centimeter cube into kilograms per meter cube. And the answer is 2,190 kilograms per meter cube. In conclusion, the density of our regular object, the cube, is 387 kilograms per meter cube. And the density for our irregular object, the pebble, is 2,190 kilograms per meter cube. Next, we would be finding the purity of a gold bracelet using the concept of density. In this experiment, we would need a gold bracelet and a 24-karat gold bar. Firstly, we need to find the density of the 24-karat gold bar, which is taken to be the purest gold. Thus, we need to find its mass and volume. For the gold bar's mass, we place the gold bar on the measuring scale and read the reading as stated on the scale. Its mass is 2,000 grams. Next, we need to find the volume of the 24-karat gold bar. We will need a beaker filled with 200 milliliters of water. Gently place the gold bar into the beaker of water. As you can see, the volume of water has risen up to 303 milliliters. To find the volume of the gold bar, we take the initial volume of water subtracted from the final volume of water in the beaker, which contained the gold bar. Thus, the volume of the gold bar is 103 milliliters, which is equivalent to 103 cubic centimeters. Finally, we are able to find the density of the purest gold, which is 2,000 grams divided by 103 cubic centimeters, which will give me 19.3 grams per cubic centimeter corrected to 3 significant figures. If we were to convert the density into SI units, we would need to convert the density into kilograms per cubic meter. Thus, the final density of pure gold would be 19,300 kilograms per cubic meter. Next, we need to find the density of the gold bracelet. We place the bracelet onto a measuring scale and read the stated reading to get the bracelet's mass. The bracelet weighs 40 grams. We now have to find the volume of the gold bracelet. Again, we place the bracelet into a beaker filled with 200 milliliters of water. The volume of water increased to 203 milliliters. Thus, the volume of the bracelet is 203 milliliters minus 200 milliliters, which will give us 3 milliliters, which is also 3 cubic centimeters. Thus, the density of the bracelet is 40 grams divided by 3 cubic centimeters, which will give us 13.3 grams per cubic centimeter corrected to 3 significant figures. If we were to change it to SI units, the density of the gold bracelet would be 13300 kilograms per cubic meter. Now, to find the purity of the gold bracelet, we would need to find the percentage of the density of the gold bracelet as compared to the density of pure gold. Thus, this would be the formula: 13300 kilograms per cubic meter divided by 19300 kilograms per cubic meter times 100 to make it into a percentage, and the answer would be 68.9% corrected to 3 significant figures. Therefore, we can conclude that the gold bracelet is 68.9% pure. Referring to a standardized graph table found on the internet, we can also find out that the gold bracelet is about 16 carat in terms of the amount of gold it contains. We hope that you have learned more about the concept density from our video. Thank you.